In this video, we'll explore the concept of DevOps Template, illustrate how to derive DevOps process from the DevOps template, and implement the DevOps process by configuring and collaborating various DevOps tools. Now, in order to define a DevOps process, plan transition, and adoption of DevOps in an organization, we need to educate teams and provide them with guidelines and schedules for the DevOps adoption journey. This can be facilitated using a DevOps template, and a template-driven approach provides the capability of deriving common vocabulary and process flow to ensure the collaborating teams have common theme and understanding. A DevOps template essentially provides a timeline for the DevOps adoption process and journey. It captures the details of each iterative DevOps task and contains brief descriptions of every phase along with the scope and vision. Some of the essential DevOps tasks that are captured along with their details include planning, development, build and test, deployment, operations, and monitoring. The details that are generally captured in the DevOps template for these DevOps tasks can include the description and objective for the plans, the development standards and guidelines for the development, continuous build, continuous testing, and automation for build and test, continuous and hands-free deployment automation for deployment, operations management, infrastructure management, continuous delivery and release guidelines for operations, along with continuous monitoring and identification of matrices for monitoring. Another important information that is captured in the template includes the recommended tools that we can use to implement each of the DevOps phases and tasks. Now, after we've derived the DevOps template and educated the teams, we need to derive a DevOps process flow that can be translated into a pipeline of implementing DevOps. A typical DevOps process, which integrates continuous delivery along with the automation of processes, is illustrated in the sample workflow figure. The process flow begins with the identification of business requirements, which is depicted in the form of use cases in the workflow. After analyzing the use cases, the development team will set up the necessary artifacts and tools to collaboratively develop the code and associated artifacts for the solution or product that is being developed. Following this, the developers will check in the codes to the code repository, from which the entire team can collaborate and process them further. The next task is to build the codes and generate binaries. In DevOps, the build task is generally automated using various build automation tools like Jenkins and Bamboo. After the code binaries have been generated, the next task is to test them. DevOps principles dictates the automation of test execution rather than manually testing the codes. The tests can include unit, integration, and functional testing depending on the requirements. Now, after we've successfully completed the testing task, we'll begin deploying them in production environments so the end users and business owners can begin using them. We'll automate the deployment process and aim to achieve hands-free deployment in this phase so we can quickly release the usable artifacts. To do so, we can use various tools like Puppet and Chef. The final task or phase involved in the workflow is monitoring. We need to facilitate continuous monitoring in this phase so we can continuously monitor various metrics that can indicate the usability, performance, and health of the systems. Now that we've explored what a DevOps template is and how we can use the template to derive a DevOps process for implementation, let's explore how to configure appropriate tools to implement the DevOps process flow. The sample illustration figure depicts how to set up popular DevOps tools in order to implement a complete DevOps process flow, starting from development to production release. We can use the first tool, Jira, to plan and document the entire implementation. We can use the IDEs like Eclipse and Visual Studio to write the codes. The codes written by the developers are then committed to a code repository, represented in the figure as Git. After the codes have been committed in Git, we can set up a continuous integration layer to build and test the codes. In the current scenario, the continuous integration layer is being set up using Jenkins, And within the layer, we've configured various tools to manage continuous and automated build and test. Maven, which is the first tool in the layer, is used to facilitate the build. SonarQube is used for code coverage. JUnit is used to facilitate unit testing. JFrog Artifactory to store the build artifacts, and Urban Code Deploy to facilitate and manage continuous deployment. We can use Urban Code Deploy to deploy the codes in various environments. This includes the deployment, QA, and production environments in order to release the product for end users and business owners.